Hello students, our first numerical on nodal analysis is to find the node voltage V1 and V2. So these node voltage are already given. So in this numerical you have two nodes, node V1 and node V2 with three dependent sources given. So we will assume at this particular node, let's say this is an incoming current, it is already given. This current I2 is outgoing current from this node. This direction is not given, so let's say I assume this is an outgoing current from this node and this is given, that is again this is an outgoing node. So we will apply a KCL rule at this particular node V1. Before that we will write down a equation of controlling parameters. So what are the controlling parameter with us is I1, here it is I2 and V1. So what is I1 basically? I1 is a current flowing through this branch which is V2 upon 10. So I can say that the first controlling parameter I1 value is the voltage V2 divided by the resistance, that is V2 upon 10 in terms of node voltages. Similarly, we can write down the value of I2. I2 is a current flowing through this branch. The node voltage at this branch is V1, so it is simply equal to V1 upon 10. So these are the two controlling parameters which we can write. Once we write down the controlling parameter equation, our next step is to apply KCL at the respective nodes. So let's say we apply KCL at node V1. At node V1, we have one incoming current, that is equal to 2I1, and the remaining are outgoing current. So let us say this is first outgoing current, which is V1 upon 10. The second outgoing current is, let's say, from V1 to V2. So we can say that we are moving from higher potential to lower potential, V1 minus V2 divided by the resistance of that branch, 10. And this is again one outgoing current directly known to us, that is 2 into V2. In nodal analysis, we want always a equation in terms of node voltages. So here in this equation we have I1 terms. So what we will do, put value of I1, which is nothing but we have already written V2 upon 10 in the above equation. So what we get when we put this I1 value, that is V2 by 10, so V2 upon 10 plus is equal to V1 upon 10 plus V1 minus V2 upon 10 plus 2V2. So in this particular equation, all the term consists of only voltages. Simplify the above equation, and after simplification we get equation as 0.2 V1 plus 1.7 V2 is equal to 0. Let us call this as equation number 1. Now we will apply KCL at node V2. Before that, let us say this is an incoming current to this node V2 because this direction is known to us. This is also an incoming current to this node V2. This one is outgoing current, and I also assume the current is going out of this node V2 towards node V1. So the equation which we write is, there are two incoming current. One is this 2V2 branch towards this, so 2V2. Another is this 2I2 current, which is incoming current towards this node V2. And there are two outgoing current. One is this V2. We are moving towards node V1. So V2 minus V1 divided by the resistance. Resistance is 10. And this is also an outgoing current, which is nothing but V2 upon 10. So as I said, we don't want I2 terms in case of your nodal analysis. But what is I2? But I2 is equal to V1 upon 10. Put in above equation. Put in the above equation and rearrange it. So we are keeping the value of I2, which is nothing but V1 upon 10 in the above equation, and simplifying the above equation. What we get after simplification is 0.3 V1 plus 1.8 V2 is equal to 0. Let us call this as equation number 2. Now we have two equations with two unknowns V1 and V2. Solve these two simultaneous equations. Solve equation 1 and 2. After solving, we get V1 is equal to 0 volts and V2 is also equal to 0 volt. So this is our final answer, that is node voltage V1 and V2 is equal to 0 volts. Thank you.